Lesson 1-3, solving equations. Today we're going to focus mostly on translating verbal expressions and also the properties of equality. So we need to write an algebraic expression to represent the sentence. 3 times the square of a number. Well, we're going to start with 3. 3 times the square of a number. We're not sure what that number is, so we need to pick a variable to use. I'm going to choose n, and we know that it's squared. So 3 times n squared. There we go. Okay, the next one is twice the sum of a number and 5. So twice means 2 times. 2 times the sum of a number and 5. Sum means addition here. So I need to put parentheses around this one because I'm adding some number. I'm going to use the letter n and 5. So the sum of n and 5, n plus 5. Okay? Twice the sum of a number and 5. That's how you can write those. All right, now we want to write a sentence to represent the equation. And I'm actually going to type this one out. Okay, so all you have to do is really say the equation and then write what you said. So if I look at this, it's n divided by 6 equals n squared. Or you could say a number divided by 6 equals the same number squared. That's how I'm going to type it out. So a number divided by 6 equals the same number squared. Squared, of course, means raised to the second power. So now you have a sentence that describes this equation. Next up are the properties of equality. There's actually 8 of these, okay? So here's 4, and then on the next slide are the next 4. So the reflexive property just says anything is equal to itself. The symmetric property says that you can switch around the equation, the left and right side of the equation. The transitive property says if A equals B and B equals C, then A must equal C, okay? If both of them are equal to B, then they must be equal to each other. And then substitution, we do this a lot in math. Basically, if 2 things are equal, then we can replace them with each other. The next 4 are the addition, subtraction, multiplication, and division properties of equality. Anytime you're working with equations, it's always okay to add the same number to both sides, subtract the same number on both sides, multiply both sides by the same number, or divide both sides by the same number. So as long as you're doing the same operation on both sides of the equal sign, then equality holds. Okay, so we need to name the properties illustrated in these sentences. Letter A, if 3m equals 5n and 5n equals 10p, then 3n must equal 10p. Well, that's showing the transitive property. You can see it here. Both of them are equal to 5n, so that means 3m must equal 10p. That's the transitive property. Letter B, if 12m equals 24, then 2 times 6m equals 24. Okay, so the equation changed a little bit. We changed 12 into 2 times 6. We're making an equal substitution here. That's the substitution property. Letter C, if negative 11a plus 2 equals negative 3a, then negative 3a equals negative 11a plus 2. Okay, so all we did here was switch the left and the right side of the equation. It's the same exact equation, just written in a different way. That's the symmetric property of equality. And the last thing that we're going to work on today is solving equations. I've got a variety of equations here that we can solve. So letter A, we need to find the value of D that makes this equation true. Negative 3/5 D equals 18. Okay, so what I like to do anytime I have a fraction multiplied by my variable is I multiply both sides of the equation by the reciprocal of that fraction, because we know by the inverse property that if we multiply reciprocals we get 1. So negative 3/5, stupid pen. Negative 3, wow. Let's try it again. Negative 3/5 d equals 18. Okay, so to solve this equation, I want to get d by itself. I'm going to cancel out my fraction. Like I said before, I'm going to multiply by the reciprocal. And the reciprocal of the fraction is negative 5/3. Doesn't really matter where you have that negative sign. And I need to do the same operation on both sides. Okay, now on the left side, negative 5/3 times negative 3/5, these are inverses or reciprocals. They cancel each other out and we get positive 1d. On the right side, I need to take 18 times negative 5/3, okay? And we get negative 30. d equals negative 30. If you wanted to check your answer, all you need to do is go back to the original problem, plug in negative 30 for d, and check to make sure that the equation is true. Is negative 3/5 times negative 30 equal to 18? And the answer is yes. Let's try another one. This time we have negative 10x plus 3 times in parentheses 4x minus 2 equals 6. We need to use the distributive property here where you see the parentheses. So that's our first step. I'm going to rewrite negative 10x, and now I'm going to distribute the 3. So 3 times 4x is 12x minus 3 times 2 is 6. And that equals 6. Using the distributive property got rid of the parentheses for us. So my next step is going to be to combine like terms. It looks like we've got two terms that have an x, so I need to add these together right here. Negative 10x plus 12x leaves me with a total of positive 2x. So my equation becomes 2x minus 6 equals 6. Okay, and then we can continue solving from there. The goal is to find the value of x, so we want to undo all of the operations on this side here. So the opposite of subtracting 6 is adding 6. I need to add 6 to both sides of the equal sign. Negative 6 and positive 6 make 0, and we're left with 2x equals 12. Now 2x means 2 times x. The opposite of multiplying is dividing, so now I'm going to divide both sides by 2 to get the x value by itself. 2 divided by 2 cancels out, and we get a solution x equals 6. Okay, and again, if I wanted to check this answer, x equals 6, you're going to go back up to the original problem, right up here, and you're going to plug in 6 for x. Replace each x with a 6, and then just use the order of operations to check that you actually equal 6 on the other side. Okay, one more that I'm going to do with you. Looks very similar. We need to use the distributive property again in 2 spots this time. So let's start at the beginning. 2 times 2x gives me 4x plus 2 times 3 is 6. Now here we're really distributing a negative 3. That's how I think about it. So negative 3 times 4x gives us negative 12, so we should subtract 12x. And then here you've got negative 3 times negative 5. That's how I think about those subtraction signs. And then I know my answer is positive 15, so I'm going to add 15. Okay, and we know that that equals 22. All right, now before you go on and continue to solve here, the right side just has 22. The left side has a bunch of terms that need to be simplified. We've got some like terms over there. I'll draw a line down each side of our equation. So on the left side, I'm going to start with combining the x's. Anytime you have like terms to put together, make sure you do it before you actually try to solve the equation. So I've got positive 4x, negative 12x minus 12x. That gives me negative 8x. Then if I look at my constants, I have positive 6, positive 15. That gives me positive 21. So the left side becomes negative 8x plus 21, and it's equal to 22. Okay, now let's solve by undoing the operation. So opposite of adding 21 is subtracting 21. The reason I do this is to cancel them out. So negative 8x equals 1. And now I'm going to divide both sides by negative 8. So negative 8 divided by negative 8 cancel each other out. That leaves me with my solution, x equals, and now I'm just going to leave this as the fraction. There's no need to calculate anything here. My answer is the fraction negative 1 over 8. And that negative sign can go anywhere. I'm going to put it out in front. Negative 1 over 8. That's my solution. Oops. Okay, now it's your turn to try a few of these. I've got 3 problems here. We'll check them again tomorrow in class.